to calculate the error is going to be really high. So this means even the value of r square is going to be morely close to 0. So it's going to be like 0.01 something, or 0.05 something like this. So this is considered poor fitting. You cannot fit a straight line to this type of data. So the error is going to be really high. So example of A and A curve would be suited to the data. So this means instead of we are going to try to fit a straight line, if we are going to fit a curve, so this curve is going to be really suited with this data. So what we need to do here, if we are trying to linearize some of this nonlinear function, remember is our previous class, we were talking about the linearization. We can linearize exponential or power equation or saturation growth. So instead of we are going to linearize this function, we can just simply fit a polynomial. We can just only fit a polynomials to the data using a polynomial regression. Okay, let me repeat again. So the model, it will help us to make the curve it's considered is a second order polynomial. This is the model, how we get it, plus the error. So if we are going to calculate the error is going to be equal to the model minus a naught minus a1x minus a2x squared. So this means if we want to calculate the sum of the square of the residuals between the data points and between our curve, which is we call it SR, we need to get the error and we need to square it. Okay, the only things is here is going to be like difference from what we have done previously is how we can get all the unknowns. Previously, for fitting the straight line, the equation is just only you are having the intercept and you are having the slope. Here we are also going to add, you are having the unknowns here, it's A0, A1, and A2. So how you are going to find A0, A1, and A2? How you are going to find these three values? To find these three values, we are going to use Navier-Gauss elimination. So we are going to use these three equations to find the values of the A1, A2, and A0. And of course, if you're going to use Navier-Gauss elimination, I think most of you still remember Navier-Gauss. So I need to eliminate this value. I need to eliminate this value. I need to eliminate this. So if you find the value of A1, you are going to substitute into the second equation to get the value of A1. So if you get the value of A2 and A1, so you're going to substitute back to the first equation to get the value of that A0. So this is the way. So if the question is coming to you at the midterm exam and didn't ask you about what type of methods you are going to solve for the polynomial regressions, by default, you are going to use Navier-Gauss elimination. If the question stated to you that you need to use Gauss-Jordan or to use Gauss-Seidel or Kramer rules, you have to follow what the question is asking you. But by default, if the question didn't ask, you go for the Navier-Gauss. Okay, clear? Any question before I go for the example? Okay. So the steps of what we are going to do here, also the same. You need to find the standard error of estimates, and of course the judge of how the polynomial is really fitting your data. It's by finding or determining the coefficients of determinations. You need to find the value of the R square, and the value of R square is supposed to be morely to equal to 1 to get the perfect fit. Okay, so we need to calculate at the end the value of R square. So this is our first example. It's asking us to fit the second order polynomial to this discrete of data. So what's the steps of how we are going to do that? I wanted to see it here in my Excel file. Okay. So for my Excel file here, I have X and Y. This is the values. What we need to do in here, you need to look at the three equations is going to give in the appendix of the paper. So look at the parameters that we need to get. The first value that you need to find is n, which is the number of the points. In my case in here, I have 1, 2, 3, 4, 5, 6. So that's mean n here is equal to 6. My n value, or the number of the points, n, is equal to 6. Okay. If we are going to look at the equation of the, standard error of estimates here, the standard error of estimate, we are going to find another parameters here. We call it m. M here is the order of the polynomial. The order of the polynomial. If your polynomial is the second order, so this means m is equal to. If it's third order polynomial, so m is equal to 3. So m here is the order of the polynomial. In our example here is asking us to find second order polynomial. So this means m is equal to. So in our example here, m is equal to. So now I find the value of n, it's equal to 6. Okay. The first parameters in here for this matrix, it's I need to find the summation of x. So that means I need to find the summation of this column. So the summation of this column is equal to 15. So here I'm going to put the value of 6, and here I'm going to put the value of 15 for my matrix. The second column here, the second elements in here for this matrix, I need to find the value of x squared. So x squared, I need to create another column to find the x squared. So I will square this value, and square the value of 1, square the value of 2, and square the value of 3. So you square all the values of all the x's. And once you're done, you need to find the summation of these values. So it's equal to 55. So this means here I'm going to put the value of 55. It's equal to the summation of column y. So this means I need to find the summation of this column. I will total up all these values. So it's equal to 152.6. Okay. So now I need now to create the second equation. The second equation, I need to find the summation of x. The summation of x is 15. Summation of x squared, I have it, it's 55. And the summation of x cubed, I don't have x cubed, so I need to create another column here to find x cubed. And I'll cube this value. So it's 0, cube the value of 1, so it's equal to 1. I will cube the value of 2, so it's equal to 8. And I will cube all the values of the x's. Then again here I'm going to find the summation of these values. So it's 225. So here I'm going to put 225. Okay. Now I need to find the summation of x times y. So I need to 0 times 2.1. I need to put it here, which is here I need to find the column of x times y. So 0 times 2.1. So the answer is equal to 0. 1 times 7.7, so it's 7.7. 2 times 13.6, so the answer is 27.2. I'm going to continue the same, and I will find the summation of these values. So it's equal to 585.6. I will put it here. So again, I will go for the next column, next row. So I need to find here x squared. X squared, I have it, it's 55. X cubed, I have it, it's 225. I need to find the summation of x power 4. I don't have this one, so I need to create another column for x power 4. So you need to do all these values power 4. And find the summation of these values. So the summation is 979. I will put it here. Okay, the last element here is the summation of x squared times y. So I need to square this value and times it with y. So I need to find x squared times y. So find the values and find the summation of it. Okay, so got those values. So it's 2488.4. So now when I created this matrix, now I need to solve using Gauss to find A2, A1, and A0. So I'm not going to explain to you how you are going to find this. So you need first to make the matrix. So you are going to eliminate these two elements. So now they are zeros. Then you are going to eliminate this value. So now you can do the back substitution to find the answer of A0, A1, and A2. So at the end, you're going to find the answers. They are equal to A0 is equal to 2.4, A1 is equal to 2.3, A2 is equal to 1.8. So now you already found those values. So now you can answer for this. You can get this. You can get this model to create for you the curve. Okay. So this is your model. Okay. So now we need to calculate the value of r square. We need to calculate the value of r square to know that is our polynomial here, it's really fitting the data or not. So we need to get the value of r square. To calculate the value of r square, I need to get the value of st minus the value of sr. And also I need to calculate the standard error of estimate. So I need to get the value of sr. So first, let's find the st. St is equal to the standard error of the sum of the square of the residual around the mean. The equation is y minus y mean square. This is st, y minus mean square. So it's 2.1 minus the average. So I need to find the average of x and y here. So 2.1 minus the y mean, which is 25.4, square the value. So you will get the answer is equal to 544.44. So 7.7 minus 25.4, square the value, you will get the answer of 314.4. Again, to continue the same, to find the whole values and find the summation of the st. I found the value of st. So now I can get the value of sr. Sr, remember, it's from our slide here, is equal to this equation here. This is how to get the sr. So I need to get this one in this column. So this is sr. So sr is equal to the model 2.1 minus a0. So 2.1 minus a0, which is 2.4, minus a1x minus a1 times the value of x, which is 0, minus a2, 1.8 times x squared, and square all the values. So the answer is 0.14. You go for the second row here, 7.7 minus a0, 2.4, minus a1x. So you are going to times with this one. So you are going to get the answer also here. Continue with all those values, find them, and find the summation. So now you get these two values. Now you can calculate sy over x and the value of r squared. So sy over x is going to be equal here to 1.11, and the value of r squared when you calculate st minus sr over st, so it's 0.99. It's almost 100% perfect fitting for this polynomial to this data. Okay, this is the example and this is the steps how to do it. Since here in the slides that we don't have exercise to do, I want you to do this example from scratch. So I'm going to give you about, let's say, 15-20 minutes to do the exercise. If you have any questions, please do ask. I will leave my speakers on. I will just only mute my microphone. I want you to try the example from scratch. And I know it's mostly the difficult parts is how you are going to deal with the naive Gauss, but try to do the naive Gauss to get those exact answer, to get the value of st and the value of sr to achieve the answer of r squared is equal to 0.99. If you have any questions, please do ask now. If not, I will give you.
Sir,
Yes.
yang M tu refer for apa
Okay.
X and Y
Okay, no, let me repeat.
Alright.
Okay. The question here for, since here we are talking about the polynomial regression, this is the standard error of estimate. It's supposed to be exactly same like what we had learned for the previous class, but you are going to find here it's another parameters here, we call it M. M is referred to the order of the polynomial. The order of the polynomial. Polynomial order. You have second order, third order polynomial. Okay, so it's referred to this number. in our example here, they are asking for second order polynomial, so this means m is equal to. If the question is asking for the third order polynomial, so this means m is equal to 3. Clear?
All right, so thank you, clear.
Okay. So back to the example here. So this is m, this is n, which is the number of the points. So try to achieve the answer of r squared is equal to 0.99. If you have any questions, I will leave my speaker on. I will just only mute my mic. Sorry, you got a problem with my connection. Have you done the example? Can you get the same exact answer? Or still okay? I give you about like 5 minutes more. Okay, anyone get the same answer for the value of the R square? Anyone can achieve? Or anyone, do you have any questions about how to do the polynomial regression? Okay, so let's move to the last thing for the regression. It's the multiple linear regression. So multiple linear regression is there's the case where the model y is a linear function for two or more independent variables. So most of the time we were dealing with the y model and x. This times we are going to deal with the model y and two more independent variables. So that means we are going to have like x1 and we are going to have another column for x2. So that means the table is coming from this exercise, or for this example, you are going to have three columns for y, x1, and x2. Do me a favor here. There's something wrong here with these equations in here. There is no bracket. You have the slides. Remove the brackets from the slides. This is not correct. This equation is not correct like this. You don't have a bracket. So this is x1 square. This is x2 square. Okay. What we are going to do with the multiple linear regression in somehow same like what we have done with the polynomial regressions, but these times we are dealing with two independent variables of x1 and x2. So the model to create the multiple linear regression, this is the model. And of course, it's going to be plus the error. So how can you again to quantify the error? By finding the value of r squared, same as what we have done before. The only thing is difference in here when you are looking at these three equations of the naive Gauss or this matrix, it's slightly different from the previous one. So these three equations in here is not exactly equal to these three equations here. They are different. These three equations to deal with more independent variables. This one is just only to deal with the higher order polynomial. So you need to focus on that. If the question is coming, they are not going to tell you exactly which equations that you need to use. So you need to know by yourself which equations that you are going to use. Okay, clear? Have any question? Okay, so how to calculate the sum of the square of the residual between the multiple linear regressions and the data? SR, this is the equation to calculate how is the SR, number is square. And also SY over X is exactly the same like the polynomial regression. There's no example. The example from this one is from the textbook 4.75, but we are not showing it in the slide. But I'm going to solve it here with you using my Excel file. So let me open the Excel file here. Okay, you see in here that we are having our example. We are having three columns. We are having x1, x2, and column y. So based on this, what you call it, the matrix, we need to get all the values. So n here is I have 1, 2, 3, 4, 5, 6. So n here is equal to 6. So that means I can create my matrix now into this form. Sorry, not here. This one. Okay, so I put my first value here, n is equal to 6. So here I need to get the sum of x1. So I need to sum all these values. So I will get the answer of 16.5. So this is the value here. I need to get the sum of x2. So calculate all these values, make a summation. So it's 14. So it's going to be here, it's 14. And the sum of column y. So the summation of it. So I get the answer. It's 54. Then I will go for the second row or the second equations. I need to get the summation of x1, so it's 16.5, and the summation of x1 square. x1 square, I don't have this one, so I need to create the column of x1 square. So I will square all the values of x1. I'll square the values, and I will find the summation of all these values. So it's 76.25. So you put it here, 76.25. And I need to find the summation of x times the summation of x2. So I need to create a new column of the sum of x1 times x2. So x1 times x2. So this is going to be here is 0. 2 times 1. So this is going to be equal to 2. 2.5 times 2. So this is going to be equal to 5. And continue the same. Okay. And find the summation. So here is going to be 48. Okay. Then you need to find here is the summation of x1 times y. x1 times y. So I need to create a new column of, sorry, not this one, x1 times y. So 0 times 5, and the answer 0. 2 times 10, so 20. So find all those values and find the summation. So 243.5. So here's the answer. Then you will go for the last equation, the summation of x2. So this is 14, and the summation of x1 times the summation of x2, we have this value 76.25. Oh, sorry, this is 48. Then find the summation of x square. So x2 square, x2 square, I don't have it, so you need to create the column. So you need to square all these values and find the summation. So it's 54. And the last one is the summation of x2 times y. The summation of x2 times y. So the column x2 times y, need the values, and find the answer. So it's 100. So once you're done, again, if the question didn't ask anything about what type of method that you want to use, so to make the elimination, use naive Gauss elimination, unless if they are asking for the Gauss-Jordan, so you need to get with the identity matrix. So in our case in here, I will eliminate these two and eliminate this. So the final answer is going to be this is the values. So A0 is equal to 5, A1 is equal to 4, and A2 is equal to -3. So once you're done, of course, you're going to find the value of ST and the value of SR is on what you have learned before to find the calculations of the value of R square. Okay. So the values of the R square is same exactly like what you have learned. So you are going to find the SR and value of SY till you get the answer of the value of R square, ST minus SR over ST. So if it's more closer to 1, so this means this multiple regression is perfect fit with the data. Okay. What we have listed here is general least square. We are not going to touch it. So this one, you are not going to get any questions from that. So I'm not going to explain. And also for the nonlinear regressions, you don't have any questions because there is a lot of matrix and a lot of transposing the matrix. So one question like this to be solved, you need a lot of time to solve it. So you're not going to get any questions from these two parts. Okay. So that's all for the theory of how to do the regressions. If you have any questions, please do ask before I move to the lab. Do you have any questions how to do the polynomial regression or the multiple linear regression? Any question? Okay, so now let's see how we can solve these things using Microsoft Excel, or how to do the regressions in MATLAB, in Microsoft Excel.